guys. All right. So I'm a little bit bummed because this is my second time filming this because first time, for whatever reason, there was no sound and I don't know how to fix that. So here we are. Take two. All right. We're going to be still multiplying binomials. Excuse me. We're going to find special products of binomials. And so we've been multiplying already. We've been multiplying binomials, but now we have some special cases. So what does that mean? That doesn't mean they're special like eat the paste special. That means that they're special because a pattern keeps happening. And when a pattern keeps happening, that means that there's a shortcut that we will get to take. And everybody loves a shortcut, right? So let's look for some patterns here. It says determine each product. So I'm going to use a graphic organizer and then I'm going to use distributive property. I'm going to be bouncing back and forth between those two methods because I know that there's probably a few of you that are still using the graphic organizer, which is totally okay. Use whatever works, you guys. All right, so I need a box. And I have an X and a positive one and an X and a negative one, or vice versa. Okay. X times X is X squared. X times 1 is X. X times negative 1 is negative X. Negative 1 times 1 is a negative 1. So when I put this together, I'll have X squared. X minus X, those cancel. So all I have is X squared minus 1. Interesting. So looking at this, I noticed that they have the same stuff, like the same letters, the same numbers, but one has a plus and one has a minus. So I'm noticing that. Letter B. X plus 4, X minus 4 being multiplied together. So I will use distributive property on this one. X times X is X squared. X times negative 4 is negative 4X. 4 times X is positive 4X. And 4 times negative 4 is negative 16. Okay, we can combine like terms on those X's there. Negative 4X plus 4X is 0. Those cancel. So all I have left is X squared minus 16. Wait a minute. In the first one, the middle terms cancel. These were opposites of each other. And here they cancel. And so all we have is the first term squared minus the second term. X squared, 1 times negative 1, negative 1. X squared, 4 times negative 4, negative 16. Thinking about that. All right, letter C. Let's use a graphic organizer. So I need X and a negative 7, X and a positive 7. X times X is X squared. X times negative 7 is a negative 7X. 7 times X is 7X. 7 times negative 7 is negative 49. Put them together, we'll get X squared. 7X minus 7X, those cancel. And minus 49. It happened again. The middle terms canceled. X times X gives us X squared. Negative 7 times 7 is negative 49. And the middle terms are gone. What is making that happen? Let's look at this last one. We'll use distributive property. 2x times 2x is a 4x squared. 2x times 3 is a positive 6x. Negative 3 times 2x is a negative 6x. And negative 3 times 3 is a negative 9. Middle terms cancel again, so I get 4x squared minus 9. 2x times 2x is 4x squared. Negative 3 times 3 is negative 9. And the middle terms go away. They cancel. Interesting. So, what are the patterns that we are noticing here? Well, let's take a look. So, we know that the middle terms keep canceling. Okay, so there's one pattern. And another thing that we should notice is that all of these have the same letters, same numbers, but the difference is that one has a plus in the middle of the two and one has a minus in the middle. So the first pattern we saw is the middle terms cancel. And number 2, they have the same factors, but one has a plus and one has a minus. Now, if you can't write as fast as me, no worries. You can always pause and then freeze the screen so you can copy that down. All right, number 3, the product of the binomials of the form a plus b times a minus b has a special pattern, and that is called a difference of 2 squares. I call it a difference of squares. You'll hear me say that for short. Use the patterns you found in items 1 and 2 to explain how to find the product of a plus b times a minus b. So we're going to use our math to do the explaining in this case. So whenever we have a plus b times a minus b, the middle terms are always going to cancel, and it's always going to be the first terms, a times a is a squared, minus the second terms, b times b is b squared. Always, always, always. And this is our difference of squares. Difference of squares. Turn the page. All right. Number 4, we're going to determine each product. Now, we're not going to do all of these. We're going to do A, B, C, and D. Actually, you know what? Those are only positive. Let's pick a couple of the positive and a couple of the negative. So let's do A, B, E, and F. Let's do that. Okay. And like I did in the last set of problems, we'll alternate between the graphic organizer and the distributive property, even though the graphic organizer is technically using the distributive property. All right, so I'll start with that. I'll put it over here on the left. I need a box. But wait a minute, I have x plus 1 quantity squared. So that means I have 2 x plus 1 quantities. So I have x plus 1 times x plus 1. Okay. All right, so if I multiply this out, I'll use the graphic organizer, x and a positive 1, x and a positive 1. X times x is x squared. X times 1 is a 1x. 1 times x is a 1x. 1 times 1 is 1. So I have x squared. This time the middle terms are not canceling. I have 2 like terms. X plus x is a 2x, and then a plus 1. Okay. So the middle terms didn't cancel on this one. So basically I have 2 of the same factors being multiplied together. They're exactly the same. Same letter, same number, same signs in the middle. And obviously x times x gives us the x squared. 1 times 1 gives us the 1. But what's happening to that middle term? How can we come up with a pattern for the middle term? So let's look at the next one. Letter B, I'll use distributive property for this one. 4 plus y quantity squared. That means I have 2 quantities of 4 plus y. So 4 plus y times 4 plus y. And we're going to distribute this out. 4 times 4 is 16. 4 times y is 4y. Y times 4 is 4y. Y times y is y squared. Now this is totally not in standard form, so we need to put it in standard form. That means list it from highest degree down to lowest degree. The highest degree is the y squared. And then I have 4y and 4y. Those are like terms. We can add them together. They make 8y. And then that constant plus 16. Okay. So we know that 4 times 4 is how we're getting the 16, and y times y is how we're getting the y squared. But how about the 8y? Well, we know that the terms are 4 and y. And you know 4 times y is 4y, but then you have to double it to get 8y. Well, is that the same as the first one? We know that x times x is x squared. 1 times 1 is 1. And if I multiply x times 1, that's a 1x. And then if I double it, ooh, I get a 2x. Okay, so it worked for 2 of them. Is it going to work for a third one? I don't know. Let's try it. Letter E. So x minus 5 quantity squared means I have 2 quantities of x minus 5. And we'll use the graphic organizer for this one. So let's see, I need an x and a -5, and an x and a -5. X times x is x squared. X times -5 is a -5x. -5 times x is a -5x. And -5 times -5 is positive 25. Okay, so, excuse me, I have x squared. A -5x and a -5x is a -10x. And there's a positive 25. Okay, so this time there's a -1 in there. All right, let's see if it still works. X times x is x squared. -5 times -5 is positive 25. X times -5 would be -5x, and then when we double it by multiplying by 2, we would get -10x. So our pattern is still working. Okay, let's try letter F. 4 minus x quantity squared. That's the same thing as having two quantities of 4 minus x. So multiply it out. 4 times 4 is 16. 4 times -x is a -4x. -x times 4 is a -4x. And -x times -x is a positive x squared. Okay, putting it in standard form, the x squared will go first. -4x minus 4x is a -8x. And that 16 is positive, so plus 16. All right, well, x times x gives us the x squared. 4 times 4 is 16. And then 4 times -x is a -4x, and if we double it, we get -8x. So far, our pattern is working. All right, so it says to describe any patterns in the binomials and products in item 4. Sorry, I can read. So there are 3 patterns going on. We know that we square the first term of the binomial, like x times x, so x squared. Square the first terms. So square the first term of the binomial. Okay. Oops. And then we also square the last term of the binomial, like -5 squared is 25. X squared is x squared, or 4 squared is 16. Same here, that one's just backwards though. And same here, 1 squared is 1. Okay, so square the last term of the binomial. Or you could say the second term, because the binomial only has 2 terms. Okay, and then the third pattern is the middle term. So multiply the 2 terms and double it. The word double in math means to multiply by 2. Okay, so the square of a binomial, whenever you have a binomial to the second power, it's called the square of a binomial. A plus b quantity squared or a minus b quantity squared also has a special pattern. Use the pattern you found in items 4 and 5 to explain how to determine the square of any binomial. So we're going to write it all nice and big. Anytime we have a plus b quantity squared, we just need to square the first term, square the last term, multiply a times b together, so a times b is ab, and then double it, so multiply by 2, so 2ab. And anytime we have a minus b squared, it's the same thing, it just means that the middle term is going to be negative. You square the first term, square the last term, multiply a times -b is -ab, and then multiply by 2 to double it, so we get minus 2ab. Sorry, I wrote that sign a little bit higher, but I was looking through the camera instead of looking at the paper. All right, turn the page. And then we're on to the homework. So this is not your homework. This you can do for extra credit, but it's all or nothing. So if you want the extra credit, you have to do numbers 10 through 18, all of them, and show all your work. Okay? You can attach it with as a picture with the assignment. That homework assignment that's going to go with this one is going to be an IXL, and you're going to see it on Google Classroom also. So don't freak out if this is the only place you're going to see it. No, you're going to see the instructions on Google Classroom in its own little assignment, okay? So you're going to do IXL, Algebra 1. You're going to do 2 of them for this lesson. Z8 will practice you on the 5.1 stuff, multiplying regular binomials. And then Z9 focuses on multiplying the special cases, like the ones from this lesson. And you need to achieve 80%. And here's another extra credit opportunity. If you score the 100%, that gets you some extra credit as well. Okay, so you can get extra credit on each of these by scoring 100 on each. And in addition to that, you can get extra credit from doing these problems. So the choice is up to you. The homework, though, you have to do. Okay, you need to at least achieve the 80%. And multiplying these are pretty easy. So this is an easy way to get some extra points, especially those of you that have had a lot of missing assignments or late work and you've had points docked. Like, this is your way to earn back those points. Or if you've missed a Zoom and you missed a warm-up quizzes, these are ways to make up those points. Okay, otherwise there's no way to make up those. Okay. All right, here you go. Have a great day.